Okay, so let's start. So today we're having one of our usual SciNet user group meetings, but because they're virtual, some people just prefer to look at the tech talk later, and that is fine. So we have a small group, so don't hesitate to ask questions as I'm going along. What are we going to talk about today? So we have a JupyterHub at SciNet, which is connected to the same file system as our system Niagara, and that's useful for a number of reasons. But in case you are lost, let me remind you what JupyterHub is. It's a notebook-style interactive Python, so you can run it from your browser, from your own machine, and you can connect either to a server that's somewhere else or a Jupyter server that's running on your own computer. And what's nice about it is that you have this idea of a notebook, which is divided into cells. Some cells could be text, some cells could be code that you can execute, and you can go back to previous cells and run them again with having edited the code a bit, and then you can create PDFs or slideshows or what have you. So it's a very versatile environment. It's not just for Python. You can use it for R, you can use it for Julia. It allows for a terminal shell to be opened, so that can be useful at times as well. So that's Jupyter itself. So if you have Python, or if you have, say, installed Anaconda's Python distribution, you already have Jupyter. Usually you can start it with Jupyter, and it'll say, go to your web browser and go. The Jupyter Hub is sort of an extension there where it is a server that allows multiple users to use Jupyter notebooks at the same time. And it allows them to, depending on the setup, it allows them to authenticate, so different users run as themselves. And that's the setup that we have at SciNet, because we have multiple users and we want people to be able to work with their own files on the Jupyter Hub. Okay. So the Jupyter Hub is conveniently accessed by jupyter.scinet.utoronto.ca, and it's hooked into the same authentication system as all of the SciNet systems and all of the Compute Canada systems for that matter. So you log in with your Compute Canada username and password. Because it runs on Niagara, you will have to have opted in to have Niagara access. So if you haven't done that, yet, go to the CCDB site and figure out where the opt-in button is, or ask us a question. But I think most of you have already got access to Niagara. If you have access to Niagara, you have access to this Jupyter Hub. What is nice is that you will find your files that are on Niagara in the Jupyter Hubs, and so that's very great, very good for pre and post processing, and just working a little bit with your files at a small scale. And I'll explain what kind of small scale we're thinking about. We also have found it useful for teaching. This idea of having text and code that you can execute. You can distribute those notebooks afterwards or at the same time to the students, that they can go through it at the same time. It's not ideal for teaching programming, because for programming you have to actually type in the code, but it is very useful for demonstrating certain techniques. And what's nice is that you don't have to install your own Jupyter Hub. So you could have Jupyter Hub running yourself in your home directory, but you'd have to install it. And if you want to do anything at any sort of scale, you probably want to run it on a compute node. So then you have to get to a compute node. You have to start your server, your Jupyter Hub server, or your Jupyter server, and then do port forwarding. That is sometimes necessary if you have larger computations that need to be done than what we allow in a shared access node like the Jupyter Hub. But for a lot of cases, you do not need to do that if we have a direct access Jupyter Hub. So that's kind of why we chose this setup. We have a bit of history in doing this. We started in 2017. We had a somewhat experimental JupyterHub setup for what was then our large machine, the general purpose cluster, the GPC. But it required you to do some SSH port tunneling, etc. But it was nice. It worked. It worked well enough that when we installed Niagara in 2018, we decided to make an externally accessible JupyterHub. So with the URL https://jupyter.scinet.utoronto.ca, but it was running on a node, not on a login node, but on a data mover node, and that was okay because we didn't quite know if it would take off, so we didn't want to make a separate node for it yet, and we did see initially just a handful of users for this JupyterHub. So that seemed okay. But now 2 years later, we routinely have 40 users running notebooks. They're not running them flat out. That's the reason that we do this on a shared machine is because when you're doing interactive work on a Jupyter notebook, a lot of the times there's no computation going on. You're typing some code or you're just exploring things, and that is fine. It means that we can have more users than cores for a node like this. But what mostly started to matter is that the amount of memory that you take when you're working with JupyterHub and you have some data loaded in, it's in memory. And so that is shared. And even if you're not using it, it's still in memory. And so we will find that occasionally the JupyterHub would crash. So it was time to bite the bullet to get an actual separate server set up to run the JupyterHub. So it's a new JupyterHub. It has more cores, and so that's good. It could potentially still crash due to out of memory, but now we'll see that that only happens if we have too many users, and we'll get to that if that's the case. And so there were issues with the old JupyterHub that needed an upgrade. Also very annoying was that if it did crash, it didn't just crash the JupyterHub, it also crashed that data mover node, and so we wanted to separate those two services. So what's new? What's new about this server? It has slightly newer architecture, but it is really mostly compatible with the Niagara nodes. That means that any environment you have, like a Python environment or an environment on Niagara, will work on this one too. It's no longer shared with the data mover. That's good. It has more cores. So the data movers have 20 cores. This one has 40 cores. They're hyper-threaded, so they're 80 cores. So it could easily run 80 things at the same time. They might not be as fast as running 40 at the same time, but it will be perfectly fine. It has a lot of RAM, so we really saw that the memory was a bottleneck, and it has some local disk available too. We haven't quite figured out how to divvy up the local disk, but that could be handy in some sort. The installation itself of the JupyterHub could now also live on local disk, which means that it doesn't have any burden on the shared file system GPFS at all. So that's nice. There's a lot of files that come into play when you're doing a JupyterHub installation, and for those of you that are doing heavy I/O, you know that GPFS is not the best at many small files. So this all helps in better performance. We've upgraded the service itself. This was a good time to do it. So you can use your own environments, and then you can set whatever versions of Python on R or even Julia you want. But the standard ones that you get have been upgraded. So Python is now at 3.8.3 in this JupyterHub. R is at 3.6.3. I'm looking into also including R4, which has come out not too long ago. The Jupyter Lab environment, which is an alternative environment to using the Jupyter notebooks, at the time that we installed the previous JupyterHub, was still in beta phase. So it was in the 0.31.5, and it's now at a very stable 2.15. So there's all kinds of niceties that come with that environment. That also means that we could now start pushing this Jupyter Lab a little bit, and I'll demonstrate it towards the end a little bit to show you what it has. It's a different environment, but it is really nice, a nice way to work, where you can have more than just basically one notebook at a time. Anyway, we'll get to that. But we've put a Jupyter Lab link even in the classic notebook. So if you log in, you will see how to get to the Jupyter Lab very, very quickly. Another thing we've added is that sometimes you have an environment that needs modules loaded. So a lot of software on Niagara is in software modules. So you have to do a module load. There was before no way to load those modules and then start a notebook. So then you're stuck, because once you're in your notebook, you can't load the modules anymore. So we've added an extension that allows you to say what modules you want loaded before you start a notebook or before you start a terminal. So those are good things. What else? Other improvements that might not seem like big improvements to some of you. First, we've dropped support of Python 2. That is to say, there is no standard Python 2 environment anymore. Python 2 is no longer maintained. If you have a Python 2 virtual environment set up, that will still work. That shouldn't stop anybody, but it's not one of the let's say official supported environments. We've also imposed a limit on memory usage, and that's meant for to circumvent or to prevent crashes. So the old JupyterHub really started to crash almost once a week or so because it ran out of memory. And sometimes that was old memory, people leaving a notebook behind, which isn't the worst thing to do if it didn't take memory, but if it had some memory loaded, and slowly over time the memory would run out. So we've done two things to help alleviate that. The first thing is to limit overall memory usage to 16 gigabytes. We will see if that's enough. We might be able to increase it, or we might have to decrease it. But at 16 gigabytes for all of the memory you're taking as a per user. So if you have two notebooks, they can have 8 gigs each, or one can have 15 gigs and the other can have 1 gig. Because there is such a limit, we've made sure that it actually tells you where you are in terms of memory usage. So at the top of the notebook, or at the bottom of your Jupyter Lab environment, it will say how much of your memory you've used so far. If you go over, so if you say allocate a list that is too large and you would go over, if you get near it, the indication of the memory usage will turn red as a warning. When you do go over, one of your notebooks is going to get killed. It's kind of like the out of memory handler that the operating system has too. So whichever notebook or environment did the largest memory allocation last will get killed. So usually that's the one you're working on, and it'll just say, hey, your kernel crashed, which means that you basically ran out of memory. You will also see the memory thing flashing red, so it should be fairly obvious. So try to stay away from that limit. Clean up your notebooks if you need more. If you need to free up your memory and use more. The other thing we did, I'm going to skip one item here, is if a notebook or your server is idle, after 4 days, they're shut down. That seems like a long time, but it is useful to have these notebooks open and then the next day come back and continue working. And as long as you don't use too much memory, we're totally fine with that. But just to put a cutoff somewhere, if you haven't looked at your notebook for 4 days, chances are you don't mind restarting it, because notebooks are easily saved and loaded again and run again. And they're not really meant to be holding a lot of data in memory forever, right? So that also helps cleaning up things, and it means that old notebooks don't matter or can't get in the way. By the way, this idea of notebooks and servers, I don't know if I've explained this clearly. The JupyterHub is a server, but then when you log in, it wants you to start a server for you as a user. So there's an overall service, and then there's a server per user, and that server is basically starting the other notebooks. So both the, now, so you can close a notebook, your server is still alive, and you can still browse through your files, that's fine. But this limitation of 4 days holds both for notebooks and servers. And usually that happens at the same time, because a server is idle when there's no notebooks going. So the servers will also be killed, which means you basically have to restart your server. There were also in the old JupyterHub some tabs that really didn't work at all, but were just there by default. There is a Conda tab that, if this is your own Jupyter installation, you can use to install Conda packages into your environment. But because this is not your own environment, that didn't really work very well. The first time you opened it, you got error messages. There's better ways to create your own environments. Just use the command line. You shouldn't be using Conda anyway. That is a different talk. But Conda is very heavy-handed in terms of how many files it uses, how long it takes to install things. It's very versatile and useful. The whole JupyterHub has been installed with Conda, so no bad words about the utility of Conda. But when you're just creating a new environment, it is a lot easier to work with just pip installs and virtual environments, especially on a machine like Niagara. There was a cluster tabs that back in the day used to start IPython clusters. Nobody uses that. It couldn't, and that tab has been, all that it said was, oh, this is now done in a different way. So those two tabs are gone and no longer in the way. Some things remain the same. If you had any existing environments that you used, they should still work. We still prefer virtual environments over Conda, and you really only need to use Conda if you use Mist. And Mist is our GPU cluster that runs on Power architecture. That stuff can't work on this JupyterHub. The JupyterHub can only work for Intel x86 or yeah, that like the ones we have in Niagara. There is a script to add your virtual environments to the JupyterHub. So when you create a virtual environment, you can create it anywhere in any directory that you want. So the poor JupyterHub has no idea where to look for your virtual environments. You'll have to basically tell it, hey, there's a virtual environment here that you could use. So there's a little script venv to that is useful to basically make your virtual environment known to the JupyterHub. The notebooks stay on the server. So if you don't, if you just close your browser, everything is still running and maintained up to 4 days. And so if you come back within that time, your notebook is the way it was before. You can have several notebooks, there's no issue. Your files on home and Scratch, and if you have project on project, are accessible. And you start off in your home directory, and you cannot cd up. So if you want to go to Scratch, you'll have to make some sort of symlink in your Scratch in your home directory, but that is a technicality. Okay, so let's try it. Let's see, and let me first ask if there's questions so far before I start demonstrating and just showing you how it goes. Okay, it's all clear. Good. Thank you. So let me start sharing another window here. Move the stuff out of the way. Okay. New share. I think it's this one. Okay, so it should be that if you go to HTTPS, and I know the font of my URL bar is small, but it says https://jupyter.scinet.toronto.ca, and it gives you this login place. So Compute Canada, username and password. Don't use your email, it doesn't work. Username and log in. So the server is starting up. This is that personal server that I was talking about. And so what it will show are the files in my home directory. Okay. Something happened here. Okay. So there's a few things to note that are different. Here's the link to the Jupyter Lab. We'll do that in a second. The control panel brings you back to being able to start or stop a server, and log out logs you out. So that logout doesn't change your running notebooks. That's something to keep in mind. And so let's open a notebook. Here's an example. There's some random stuff. Okay. So one thing to note is the memory usage that is listed here. And so I've got some packages I import. Let's forget about this stuff. I was playing around with that. Let's say I want to allocate some NumPy arrays, some random ones, fairly large. As it's going, it will show that the memory is now 3 gigabytes. So it's a fairly substantial array. And so it's fairly easy for me to basically crash this kernel by just keep doing this. There. Now it's 9 gigabytes. Where are we going? It's going to take a little while. I don't think 5 is enough. Nope. But we are getting close. So now it's telling me, hey, you're almost out of memory. Very close. And so if I did that one more time, this is what happens. So if you saw very quickly, you saw that it went to 18 gigabytes. And then you get this kernel restarting. It seems to have died. It died because of the memory overage. Now, unfortunately, although it starts the kernel again, apparently the interface doesn't realize that the kernel is not dead. So the kernel is alive, but just started over from start. I like to just refresh the page so that Jupyter will figure out that it's not a dead kernel. It just annoys me, but there we go. Now we're back to normal. So that is a feature that might be annoying. I don't know if any of you are running much larger data sets and need more. Let me know. Let us know. This is something I sort of chose, given this the 1 terabyte of memory and the number of users that we kind of have. It's so 16 gigabytes is the current maximum. But as I said, it's meant, there should be some maximum. If you really need a lot of memory, you should just write a script that runs on Niagara, and that is fine. But if you say, no, I routinely need like 20 gigabytes, and then that's probably still okay. It's kind of a random number I chose so far. But it will never be like 64 gigabytes. That is just too much memory. And at that point, you're looking at a substantial amount that you should run differently. Okay, so let's look at the Jupyter Lab. So there's a nice button here. Oh, by the way, this is Python 3.8, 3.83, I believe. Let's go to Jupyter Lab. Leave the side. Yeah, that's okay. it looks quite different. So you've got your files on the left here. You've got different environments that you have. Python 3 is the standard Python 3.8. R3.6 is available. This is a Conda environment that I created to show that you can have your own Conda environments here. You should really use virtual environments. I like the fact that the Conda environments pop up with such an ugly title with Conda brackets, and just aesthetically, you should not like this. In any case, you could open a notebook. There you go. You could open an old notebook that was already there. So select the kernel, apparently. It's okay. There's fun things you can do where you can drag your tabs to different places and have a split screen. You can get a new terminal somewhere here. Here's a terminal. The terminal works. There we go. That's my files again. The terminal can also be useful to create your own virtual environments, which you could do on Niagara too. Doesn't matter where you do it. Oh, and then let me demonstrate where the software modules go. So suppose that I wanted to use, say, maybe I have an environment that needs netcdf, but it's not loaded. So if I click on this hexagon here, this blue hexagon, it shows me what modules are available. They're just the Niagara modules. So we've got our 2019 B stack loaded by default. Now you know probably that there's modules that depend on other modules, so they have to be loaded first. So I could try and load, say, a compiler module. Click on it, and it adds it here. And then, because I've done that, the number of modules is going to increase. I should now have other packages like OpenMPI that weren't there before. Maybe you want to try and load, what should I load? Blast, for instance. So if I click on it, it tells you what to do. This is going to be useful, but let me try to load it first. I'm loading this. Okay, did it work? No. Why didn't it work? Well, it didn't work. It should have given an error message. The plugin isn't sophisticated enough to do that, but it didn't load because it needs other packages. So if I click on the name, I can actually see what it needs. It's a little cryptic, but it does say that it requires LMDB and GMP and Boost. So I will have to load those first. Let's see if I can do that. Here's GMP, load that. I need Boost. What did it need? What else? LM. Go. Oh. Load it. Okay, so now that I have those, I should be able to load Blast. And there we go, it worked. Now, right now in this environment, I still have no modules loaded. And likewise here, this one will not have it. But if I started a new terminal or a new notebook or a new R notebook, I now have those modules loaded, and I could do blast runs. That's it. Okay. What else? I think that's it. Your running kernels and jobs are all here. Move this a little bit. Give your notebooks better names than I have. Example and Entitled 1 and Entitled 2 are shameful titles, but hey. You can shut them down here. Yeah, okay. So let me just show you then last. Yeah, so the Jupyter Lab was always there, but it was a beta version. So you had to know to change the tree word in the URL and replace it by lab, and then it worked. But especially nice is a lot of the plugins have really come along. Okay, so let me just show you how you get a virtual environment in here. And I think I even made a, yes. So it's pretty simple, but the easiest way is to do it in a terminal. So I'm in a terminal here already, so that's good. So let's say I wanted to create a virtual environment. I want to load a Python. I always start with some base Python. So the Python that comes with this Jupyter Hub is 3.8.3, but it's a Conda version. So when you want to create a new virtual environment, you don't want to start with that. You want to start with a plain Python, like our Python 3.8.3, which this is, oh, I guess it's not 3.8.3, it's 3.8.5. Oh, even better. So that's the Python now. Which Python? Yeah, okay, so that's good. I can create a virtual environment. I always like to add all the system side packages because our this Python comes with NumPy, SciPy, Matplotlib, I think even Pandas. There's no need to reinstall those in your own virtual environment. So let's not. And let's say we wanted to create a virtual environment with my .jet virtual and for BioPython. It's a nice package. Yeah, it's a bit verbose. Older versions of Python weren't this verbose, but everything went well. The dollar question mark is 0. So now I can activate that. In the usual way, source, it's been activate file. Now I have BioPython, but I haven't installed anything. This is just the same Python, so I'd have to pip install, say, BioPython. Okay, it seems to be doing it. Successfully installed it. How would I know? Well, I just start Python and I import. In this case, the name is called bio with capitals, and that works. Great. But that's in the terminal. Now I want that to be known to the Jupyter Hub. So as I said, there is a command that's specific to Niagara, vn to jup. But it does a few things, and I'll tell you what it does. So let me run it. So you have to be in a virtual environment. So I am in a virtual environment, and just type it, and it'll figure out what environment you have, and it'll do a couple of things. The first thing it does, let me scroll up, is to try and install a package called ipykernel. That is the thing that makes your environment work within the Jupyter Hub. So if you already had a virtual environment somewhere, you could do vn-to-up, that's fine, or you could do pip install ipykernel, and that would make your environment capable of running in the Jupyter environment, but it wouldn't tell the Jupyter environment that your environment exists. So it can do it, but the Jupyter Hub doesn't know about it. So that part, so that this requires all of the installations, that last part is really just creating a file in this directory called in your home directory .local share Jupyter kernels biopython. It even puts the environment changes in there. So the modules I had just loaded are actually baked into this environment now, which is kind of nice. So biopython can actually use BLAST, turns out. So I don't have to load the modules and then start the notebook for this case, but you might like to do this separate. In any case, this should now have worked. So let me see if it now has added this environment to the list of possible environments. Yeah, and lo and behold, here it is, BioPython. I can click it, it starts a new notebook. It'll tell you that it's in the BioPython. And if I import bio, it actually works. Version. Yeah, there we go. So I don't know if I have more to add. If you do have Conda environments, and again, I have to say, please try not to. You're going to run out of file numbers very quickly. Usually you can use it, just pip install for almost anything. Even if the even if the instruction of a package say that conda is the best way to go, yeah, try it with pip. It probably works too. And it's better for this environment. In any case, if you have a conda environment, conda install ipipe kernel will also do the same thing, where it'll make the environment suitable for the environment. And that's actually what I did for this guy here. You can go back from the Jupyter to the classic notebook. For some reason, it's under the help. That makes no sense to me, but in any case, there's a lot of references here in the help that are useful, but you can go back to the classic notebook, and there we are. The same idea of loading software can be done in the software step here. It shows you what's loaded. It works very similarly to what I just showed on the Jupyter Lab side. And things are running. It is a little unfortunate that you don't see the maximum memory in this, or the memory used here. You'd have to go into a notebook to see it, but yeah, such is life. Keep in mind the memory limits. If you're using a terminal, whatever you use in the terminal is also counted towards the memory there. And so yes, that's and let us know if the 16 gigabytes is going to bite you too much. There has to be a limit, but it doesn't have to be exactly 16. But right now it is. Like that's just how it is. More is better. Yeah, we'll see how it goes. If you have just one notebook, I would think 16 gigabytes is pretty okay. But I can imagine if you have a lot at the same time, it could be troublesome. Then again, is it fair to give somebody that has more notebooks more memory? I don't know. Questions? So I think most of you were running on the old notebook already. So that will be kept alive for a few more days until Friday. You would have to go to old Jupyter.SciNet.utoronto.ca, and then your previously running notebook should still be there, but we'll shut it off at Friday. How can I go back to the previous kernel if you accidentally closed the tab? Oh, so if you close a tab, if you close one tab, you'll probably get back to your files, and so you can just click there. If it's just closing the tab, it will still be running, so it'll be in the running tab, and you can click there. If you accidentally close this or close everything, you could just go back to JupyterHub. So bookmark that, and it will know you're still logged in, so it gets you here, and you can go to your running stuff there. Is there a limit to how many users can connect at the same time? No, right now, there's no limit to how many can connect at the same time. The connection hasn't been an issue for the Jupyter Notebook, as far as we could tell, even for the old one, for the JupyterHub. So we're not restricting that at the moment. So you'll always get in. It's kind of like the login nodes. You can always get into a login node. And it is possible for people to hog the system, but not for a very long time. So if somebody is running a very heavy calculation, if they're using just one core, they can run it for 6 hours, but there's 39 other cores available. If they're using they're using a parallel package, that 6-hour limit gets divided by the number of cores you're using. So even if there is some intentional or unintentional abuse of the system, it would never last for very long. Yes, so in principle, you can use 40 cores. I haven't really played with it too much. It might be that if it happens a lot, we might restrict it to using, like, I don't know, 8 cores at most or something. But right now, there's no restriction. You should be able to do, say, multiprocessing with 40 cores. Don't keep it small because it's a shared resource, and we will be able to see what you're doing. The monitoring on this system is a lot better in the old system, where all we would really know is that it crashed at some point. We can go in and see who is doing what. We're not doing it purposely, but if something is going on. So keep it modest. If you really have to use 40 cores, you might as well write a script and run it on Niagara, right? The kernel will crash when you go over the 6 CPU hours. I think that's how it works. And that's it's slightly annoying, but I don't have a good way to limit the CPU from within Jupyter. So it's just done externally by the OS, and all the OS can do is kill. It will try to restart, I think, automatically. So it should do one of those things that we saw with the memory, where it says, oh, the kernel crashed, but then it restarts the same kind of kernel for you again. It's just all the data that you had and all the variables are gone, which is not nice, but that's what you have. So yeah, if you think of running this for production, you should really think of switching to a batch job on Niagara, even for just predictability, right? We just launched it today. I've been working on it. So it was used during the summer school. We had a summer school this summer, and it was used for that. So it had been tested in production, and that worked well. We had at times many dozen students using it at the same time. So that told us that it can handle this load. But today is the official date that we're switching from the old notebook to the new, the old JupyterHub to the new JupyterHub. Are we going to do another HPC Python this year? Well, certainly next summer. I do not know if there's going to be another HPC Python session before that. But you would be interested in having one sooner? Because we can keep that in mind when we're planning. We haven't planned the whole spring yet, although a lot of things are of our training sessions are already there. Yeah, so at the very latest next summer for sure. Yes. Are there any features that you feel you would like to see in here? And maybe they're already in there and I just didn't talk about them, but something that you've heard about or that you thought would be good to have, because it's still early and you know, it's not too much work to make small changes or add a package here and there. The standards Python has a lot of packages in it. It has NumPy, SciPy, Matplotlib, Plotly, Pandas. I put in TensorFlow. It's a CPU-only TensorFlow, so I think Keras is in there. It might even have PyTorch. It's meant to be somewhat complete in that you don't necessarily have to create your own environment to start using it, but sooner or later you're going to have specific version demands and you're going to have to do that. But yeah, not every usage of it should require you to install packages, right? So any requests? You can always come with a request later. Just write to support at SciNet@utoronto.ca and say, hey, I kind of like this extension that I found and we're using it, but it's not available. Some of the extensions, they have to be installed sort of system-wide, but if they don't bite the rest of the system, I don't mind putting them in. That's fine. Yeah. Okay, well, if there's no other questions or suggestions, we are nicely at the 1 o'clock mark. So I'll thank you all for attending, and I'm going to try and post a recording too if you want to share this with other people. But